two-part series, and we're going to talk about operations with polynomials such as addition, multiplication, distributive property, and division. But today specifically, we're going to learn how to simplify expressions and remember our exponent rules. So let's get started. So first of all, we need to understand what simplify means when we're talking about algebraic expressions. So to simplify an algebraic expression that has powers in it, that means that we're going to rewrite that expression so that it doesn't have any parentheses when we're done. There should be no operations that we can still do, like no addition that can still be done, no multiplication, no division. And we need to make sure at the end we don't have any negative exponents in our expression. If so, we need to adjust that accordingly. So let's talk about our powers first. So we're going to look at a series of powers with bases of 2 and bases of 3. Now I'm going to start with 2 to the first power because we all know that 2 to the first power at this point is simply 2. But we're going to watch what happens as we move up our table. So if we take 2 to the second power, we remember that that means to multiply 2 times itself twice, or give us 4. Same thing with 2 to the third. I get 2 times 2 times 2. I multiply 3 2's together. That gives me 8. And 2 to the fourth power would be 2 times 2 times 2 times 2, or 16. Now notice that when I'm not changing my base, as I move up an exponent, so as I move from 1 to 2, I am multiplying by another 2 each time. So that must mean that as I move down my chart and I lower my exponent by 1 every time, that I divide by 2. So as I lower from 3 to 2, I take my 8 and I divide by 2, and that gives me 4. As I go from 2 to 1, that's like taking 4 divided by 2, which gives me 2. So then that helps us understand when we get to something like this, where it's 2 to the 0 power. Because if as I move up my table, I multiply by 2, and as I move down my table, I divide by 2, when I take 2 to the first power and I divide that by 2, that's simply going to give me 1. Now, is that a special case? It is. Does it work for only 2's? Well, let's see in a minute, because I want to continue this pattern and see what happens when I subtract another 1 from my exponent. So you probably have never seen this point, up to this point, a negative exponent. But I keep continuing this pattern in this table, so what I'm going to do is I'm going to divide by 2. So 2 to the negative 1 power is simply to divide by 2, or making this 1/2. As well as 2 to the negative 2 power, well, that means I need to divide by another 2, which would give me 1 divided by 2 squared, or simply 1/4. So what I want you to see today is when I expanded all of these numbers, including these negative exponents, it didn't make any of my numbers negative. But when I used these negative exponents, it just changed my operator from multiplying my powers out to dividing my powers out. All right, let's see that happen with 3. So as I move up, I'm going to start with 3 to the first power again, and that's going to give me 3. 3 to the second power, 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So once again, you can see as I move up, as I add an exponent, I'm multiplying by a power of 3. But as I move down my table, I'm dividing by 3. Divide by 3. Divide by 3. And I continue to do that. So when I get to 3 to the 0 power, I take my 3 to the first power and I divide it by 3, giving me 1 again. So you can see that that special case is going to hold true for all integers, except there's one exception to that rule, and that would be if the base were to be 0. All right, so let's see what happens if I divide by another 3. So when I divide by another 3, 3 to the negative 1 power, that gives me 1/3. Again, I want to repeat, I don't have negative 1/3, I just divide by a power of 3. And I continue to do so. One more time, if I divide by 3 squared, that simply gives me 1/9. So when you see these negative exponents, I need you to remember to divide by the power. Now we're going to talk about that a little bit more as we move forward, but I need you to understand that that negative exponent will never make a number negative. It means to divide by the power. Okay, so let's go back to our exponent rules that we've learned in Algebra 1. Now, all except these last two, you came straight from Algebra 1. First is when I'm multiplying with like bases, and my two like bases have powers. You might remember, now this is called the product of powers if I give it a name. Product of powers means that I have the same base. So repetitively, that means that I will repeat the base and I will add my exponents together. All right, now an example of that would be if I had x to the second power times x to the third power. Well, this would mean that I'd have 2 x's, and this would mean that I'd have 3 x's. So altogether, I would have x to the 5th power. So when I have a product of powers, I repeat the base and I add my exponents. So my next rule is very similar, except it's the quotient of powers. Okay, so when I have the quotient of powers, instead of repeating the base and adding the exponents, I'm going to repeat the base. Now notice that these bases are the same, but I'm going to repeat the base and I'm going to subtract my exponents. So an example of this would be if I had x to the 5th power divided by x to the 2nd power, because that would mean that I have 5 x's on top and only 2 x's on the bottom. So 5 minus 2 would leave me with x to the 3rd power because I would subtract 5 minus 2. Now my third rule is a power of a power. So you can see that I have a base that I'm raising to another power. So I have x to the a power being raised to the b power. So you're seeing these double powers come into effect. Now the rule for raising a power to a power is to keep the base the same, but this time you're going to multiply your exponents. Now let me make this a little bit clearer so you can see that that's a subtraction and that is raising a power to a power or multiplying your exponents. Okay, so an example of that would be if I were to take x to the 2nd power and raise that to the 3rd power. That would mean that I have 3x squareds, or 2 times 3, that would give me x to the 6th power. Okay, now this next rule I need you to be careful with because this rule only applies if I have a product inside or a quotient. So this is the power of a product rule. So this is if I have 2 bases, and you can see that they're not the same this time, but they're being multiplied together. So you don't see this rule for addition and you don't see this rule for subtraction. This rule is specific to only products and quotients. What this rule says is that when you have a product inside and both terms are raised to a power, you can separate and distribute that power to both terms. Okay, so an example of this could be if I have 3x and I'm raising that to the 2nd power. So what I can do here is take each term individually and square that. So 3 squared would give me 9, and x squared would just give me x to the power of 2. All right, so how does that work if it's a quotient, a power of quotients? Write that correctly. It works the same way, but you're going to separate your numerator from your denominator. So if I have x divided by y to the 8th power, I can distribute that a power to both terms and separate each individually. So how does that look? So maybe my example is x to the 2nd power over y, and I'm raising that to the 3rd power. So individually, I'm going to take this power to power on top. X squared to the 3rd power will give me x to the 6th power. And then on the bottom, this power is 1 if I don't see it. So y to the 1st raised to the 3rd would simply be y to the 3rd power. Now, all of those are rules that you learned from Algebra 1. So those have not changed. That should just be a review for you. What is new to you, or maybe a little less familiar, is our negative exponent rule. So this is the one I just talked to you about. Now, when you see this negative exponent rule, I want you to think division, because that's what that means. It means divide it by the a power. So I'm just going to flip this over and make this 1 divided by x to the a power. Now, an example of this is if I have 4 to the negative 2 power, that means I'm going to divide it. 1 divided by 4 to the 2nd power, or 1/16. And x to the 0 power. X to the 0 power, no matter what our integer or our number is raised to the 0 power, it's always going to be 1. Now remember that the only exception to that rule is x cannot be 0. If x is 0, then 0 to the 0 power is going to be 0. All other numbers will give me 1. All right, now I know I keep talking about this negative exponent rule, but I want to make sure that we understand it completely. So I want to talk about it for just a few more minutes. That negative exponent means, again, to divide by the power. So I want to show it to you because sometimes that negative exponent comes on the bottom. So now it becomes a little trickier. So it says for any real number when a does not equal 0, because division of 0 is not allowed, and any integer n, a to the negative nth power becomes 1 divided by a to the nth power. Notice that it didn't become negative, it just became a division problem. So an example of this, so it shows you here 2 to the negative 3rd power. So that's like taking 1 divided by 2 to the 3rd power. And if I extend that, that's 1 divided by 2 times 2 times 2, or 1 divided by 8. All right, now they show us that 1 divided by b to the negative 8. So what happens when it's on the bottom? So let's see this. So what I have here is 1 divided by b to the negative 8. So what that means is this is 1 divided by b to the 8th. And remember our fraction rules, in order to divide by any fraction, we're going to flip that and multiply. So technically this is going to become 1 times the reciprocal of 1 over b to the 8th, which becomes b to the 8th over 1, or simply just b to the 8th. So what you'll notice here is that if my negative exponent appears in the top of a fraction, it's going to go to the bottom. However, if it appears on the bottom of the fraction, we're going to move it to the top, and it's going to become b to the 8th power. So basically, you can think of it as moving it from the numerator to the denominator, or vice versa, the denominator to the numerator. All right, so let's start simplifying some of these expressions and seeing how all of these rules work together. So our first example, Simplify negative 2a to the third b times negative 5ab to the fourth. Now everything's being multiplied. So what I'm going to do is I'm going to multiply all of my like terms. So I'm going to multiply my coefficients first. Now nothing fancy there, just negative 2 times negative 5. And negative 2 times negative 5 is going to be positive 10. Then I'm going to take a to the third times a, and that's going to be the first power. So that is like bases, so you'll remember that I repeat my base and add my exponents. So far I have 10a to the fourth power. And then I'm going to group my b's together. B times b to the fourth. Again, remembering that that's 1. Repeating the base and adding the exponents gives me b to the fifth power. And that is simplified. So you can see that I don't have any parentheses and all of my exponents are positive. All right, so I got a lot going on in this second example here. 3a to the fifth times c to the negative second times negative 2a to the negative fourth times b cubed. All right, just like I did in the last one, I'm looking for my coefficients. So I only have 2 coefficients to multiply together. That gives me 3 times negative 2, or negative 6. Then I'm going to group all of my a's together. A to the fifth times a to the negative fourth. I only have one b, so he's going to be by himself, and I only have one c, so he's going to be by himself. So I'm going to apply the rule here, repeat the base and add the exponents. That's going to give me a to the first power. So I have negative 6 times a to the first power times b to the third power. Now I have c to the negative second power. Now remembering that that just means 1 divided by c squared, or I can rewrite this all as negative 6a b to the third divided by c squared. So I taken what was my negative exponent and moved it to the denominator. Now notice I didn't move the negative 6 down. That's not a negative exponent. That's just a coefficient. That's a negative number. So this is my final answer, negative 6ab cubed divided by c squared. All right. So now we have an example that shows division. So this was that second rule where we have a quotient of powers rule. So when I have like bases, the rule is to take the like base, keep the base, and subtract the exponents. Well, when I take 2 minus 10, that gives me s to the negative 8 power. Well, to the negative 8 power means divide by the power of divide by the power of 8. That gives me 1 divided by s to the 8th power. Now my values are simplified. Now to show you another way, if I expand that, I could expand that too, which means I have 2 s's on the top and 10 on the bottom. 1, 2, 3, 4, 5 more. And s divided by s simply becomes 1. So I can knock out 2 of those all together, which leaves me with 1 on top. And look how many I have. 1, 2, 3, 4, 5, 6, 7 s to the a power in the denominator. All right. Just a little expansion so that you completely understand. All right, so our third example is going to use the power of the powers. So you can see here, and it also is using the power of the product because I have more than one number inside of here. So I'm going to go ahead and distribute that third power to everything inside because it's all multiplication. Remember, if I have addition or subtraction in there, this rule does not work. It's null and void. All right, so I'm going to take each number to the third power. So you can see I keep the exponents on. Then I'm going to go ahead and raise this. So this first number becomes negative 3 times negative 3 times negative 3, or negative 27. Now I raise my power to a power. That's going to give me c to the 6th power. and power to a power gives me d to the 15th. So this gives me negative 27c to the 6th, d to the 15th. Now, same or similar rule, but it's the quotient of powers. So I'm going to go ahead and distribute that 5 inside. So this is going to give me negative 2 to the 5th power. It's going to give me a to the 5th power and b squared to the 5th power. Now I'm going to go ahead and work each piece out. So negative 2 to the 5th power gives me negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which altogether is negative 32. A is already raised to the 5th power, and now I can handle my b to the 2nd to the 5th and multiply those out to give me b to the 10th. I look around, I have no negative exponents, so I am as simplified as possible. All right, and my last example is going to use several different rules in here. Now, what I have inside is negative 3a, and that a is raised to the 5y power, divided by a to the 6y power, times b to the 4th, and it's all being raised to the 5th power. Now what I'm going to do first is I'm going to look inside and see if there's anything that I can simplify. So I'm working inside my parentheses first. I notice that I have like bases inside, so I'm going to handle this division, and since it's division, I'm going to have to take and subtract my exponents. So I'll have 5y minus 6y, which is technically a to the negative 1y power. Because it's negative, it's going to go to the bottom. So I can rewrite this now as negative 3 divided by a to the y power, b to the 4th, and this is all raised to the 5th power. So now I will go ahead and handle my power distributions. So this is going to give me negative 3 to the 5th power divided by ay to the 5th power and b to the 4th to the 5th power. Now quick calculations, negative 3 to the 5th power, if I calculate that out, is going to give me negative 243. Again, I'm not moving that, it's just a negative number. And then I'll do these power to powers. So this is a to the 5y power and b to the 20th power. So when I'm done, I have no negative exponents, only a negative number. Okay, so we covered a lot of exponent rules today. So look for your practice on Google Classroom. Have a nice day. We'll conclude with part 2 tomorrow.